Hello, everybody. Welcome back to mathematics. Today we are going to learn what improper fractions are, how the mixed numbers are related, and how we can convert from one to the other one. Let's start remembering how to represent a fraction. We know that we have numerator and denominator. The denominator tells us in how many parts to divide the unit. So if we have this unit here, we would divide it in 5 parts in this case. And we would take 4 of them. And that is the representation of 4/5. But how to represent the opposite, 5/4? Again, the denominator is telling me to divide the unit in 4 parts. And we take 5 of them. 1, 2, 3, 4, and wait a minute. I need to take 5, but there's just 4 here. That means we are going to need another unit. Divide it by 4 parts again, and then take the other part that I needed. Then I have 5/4. In those cases where we need more than one unit, that's when we are talking about improper fractions. That happens when the numerator is bigger than the denominator. Let's try that. Let's remember here that the numerator goes at the top and the denominator goes at the bottom. So every time the numerator is bigger than the denominator, then we have an improper fraction and we are going to need more than one unit to represent that fraction. So in that case, we have the 5/4. There is another way that we could represent this, and that is using the mixed numbers. Because notice that we have a whole unit here. So we would say this is one whole unit. And this one is a fraction. This fraction is 1 out of 4 parts. So this fraction is 1/4. And that's why they are called mixed numbers, because they are composed of a whole number and a fraction. So we could say that 5/4 or 5/4, they are the same as 1 whole and 1/4. They are the same. And this is the representation of both. But doing the drawing is not the only way to convert it, because sometimes the numbers are going to be too big and the representation is going to be very difficult to do, like so many whole numbers, so many pizzas to divide. So there's another way to do it. Remember that a fraction is always a division, so this is also equals to 5 divided by 4. So another way is to do the division with a remainder, 5 divided by 4. 5 divided by 4 is 1. 1 times 4 is 4. And then we do the subtraction. 5 minus 4 is 1. This is the remainder. Then we could write that 5/4 is equals to 1, which comes from the result. At the top is going to be the remainder, which in this case is also 1. And over, we are always going to have the same divisor here. So the same denominator as the beginning, 4. That's another way where you could convert from improper fraction to mixed numbers. Or let's say we want the opposite. We have the mixed number and we want to go back to the improper fraction. Again, we could do the representation. It says that the units are going to be divided by 5. And we are going to have 2 complete ones and a fraction of the third one. So we are going to draw 3 of them, all divided by 5 parts. Here we go. And then we select 2 complete ones. and 2/5 of the last one. This is the representation. So we can basically count how many fifths we have here. So the denominator is again going to be 5. Always the denominator is the same because the amount of slices that we take from the pizza, they are the same. Then what we need to do is to count how many fifths we have in this case. Let's see. 12 fifths. So that means this is equals to 12 fifths. So one more time, we have 2 wholes and 2/5 is equals to 12 fifths. But again, we don't need to do the drawings the whole time. There's another way to do it a little faster. So if I know that the complete units are going to have 5 pieces each, then I should multiply the whole units by the pieces that they are going to have. So we are going to multiply here 2 whole units of 5 pieces each. We multiply. And then we add the number at the top because that would mean the additional pieces of the incomplete unit. So that would make 2 times 5 plus 2. 2 times 5 is 10, and 10 plus 2 is 12. And like that, we find that 2 wholes and 2/5 is the same as 12. And remember the denominator, always the same. So 5 again. 12 fifths. Okay, guys, it's time for you to practice. So try to solve these ones and come back for the solution, okay? Okay, let's check. I'm going to do the representation for this first one. 1, 2, 3, 4, and 5 halves. Then I have 2 whole ones and 1/2 of the next one. So this is 2 wholes and 1/2. For the next one, I'm doing the division. 13 divided by 3. That is 4 times. 3 times 4 is 12. 13 minus 12 is 1. So that means the result is the wholes, 4 wholes. At the top goes the remainder, and the denominator is the same. 4 wholes and 1/3. I'll do the division for the next ones too. 4 times 3 is 12, and the remainder is 3. 3 wholes and 3/4, or 3/4. And finally, 11 divided by 5. It's 2. 2 times 5 is 10. We subtract and get 1. So this is 2 wholes, the result, 2 wholes, the remainder at the top, and 5. 2 wholes and 1/5. Now let's go with these ones. I'm going to do the representation for the first one. 1 whole and 1/2. So if we count, we get 1, 2, and 3. 3 halves. For these ones, I'm going to do the multiplication and addition. 2 times 4 is 8. 2 times 4, and then plus 3. 2 times 4 is 8, plus 3 is 11. Then the result is 11 quarters. Remember, the denominator is always the same. In this one, 5 times 5 plus 3. 5 times 5 is 25, plus 3 is 28. 28 over 5. And finally, 2 times 10 plus 3. 2 times 10 is 20, plus 3 is 23. 23 tenths. And that's it. Don't forget to subscribe, book your own lessons with me, and drop any questions or any topic that you want me to explain on the comments box. Bye bye, guys. See you next time.